Yes. Hello everyone, I am an MTech student in VIT University and today we are going to do a project in next word prediction in natural language processing. By seeing the image itself, you will come to an idea about the project. Yes, we are going to predict the next word, what you are going to enter in the search box. Let's enter into our project. Predictive text. This is about word completion on limited keyboards, like it's mobile phone keyboards, for a similar article for general keyboard. See autocomplete, predictive search, redirection. Predictive text is an input technology used where one key or button represent many letters such as on the numeric keypads of mobile phones and accessibility technologies. Each key press results in a prediction rather than repeatedly sequencing through the same group of letters it represents. The same invariable order. Predictive text could allow for an entire word to be input by single key press. Predictive text makes efficient use of fewer device keys to input writing into text message and email and address book and calendar and the like. The most widely used general predictive text systems are T90, T9, ITAP, EZIText, and later based or word based. There are many ways to build a device that predicts text, but all predictive text systems have initial linguistic settings that offer predictions that are pre-prioritized to adapt to each user. This learning adapts by way of device memory to the user disambiguating feedback that results in corrective key presses, such as pressing a next key to get the intention. Most predictive text systems have a user database to facilitate this process. Theoretically, the number of keystrokes required per desired character in the finished writing is on average comparable to using a keyboard. This is approximately true providing that all words used or in database punctuation is ignored and no input mistakes are made by typing or spelling. The theoretical keystroke per character KSPC of a keyboard is KSPC is equal to 1 and of multitap of KSPC is equal to 2.03. Yetnomi letterwise is a predictive multitap hybrid, which when operating on a standard telephone keypad achieves KSPC is equal to 1.15 for English. The choice of which predictive test system is the best to use involves matching the user's preferred interface style, the user's level of learned ability to operate predictive text software, and the user's efficiency goal. There are various levels of risk in predictive text systems versus multi-tap systems because the predicted text that is automatically written that provides a speed and mechanical efficiency benefit could if the user is not careful to review. Result is transmitting misinformation. Predictive text systems take time to learn to use well, and so generally a device system has user opinions to set up the choice of multi-tap or any one of the several schools of predictive text methods. The next word prediction for a particular user texting or typing can be awesome. It would save a lot of time by understanding the user's patterns of texting. This could also use by a virtual assistant to complete certain sentences. Overall, the predictive search systems and the next word predictions is a very fun concept which we will be implementing. Comes the prediction of next word. Till now, we saw how an LSTM works and its architecture. Now comes the application part. Predicting the next word is a neural application that uses recurrent neural network. Since basic recurrent neural network have a lot of flows, we go for LSTM. Here we can make sure of having longer memory of what words are important with help of those three gates we saw earlier. The following diagram tells us exactly what we are trying to deal with. What could be the next word? We will build a neural model to predict this. Suppose if we type that as a student open there, if the example selected the books or laptops or exams minds, these are all the predictive words which will come next. They can be anything. The students open their exams, the students open their laptops, or students open their mind, or the students open their books. Anything can come. These all the words are the predictive words. This all we are going to do. Next word prediction is an application of NLP, natural language processing. It is also known as language modeling. Basically, it is the process of predicting the next word in a sentence. It has many applications, which are used by most of us, such as autocorrect, which is mostly used in emails, messages. It has also its usage in MS Word, Google search, whereas forecast the next word based on our search history or search we did it for Globe. LSTM model, long short-term memory model, are used to solve the problem of short-term memory by using gates that regulate the flow of information. These models have mechanisms that decide whether or not to keep information, thereby being able to retain important information over a long time. Due to their ability to learn long-term dependencies, they are extensively used in machine translation, speech recognition, handwriting recognition and generation, language modeling and translation, and speech synthesis, and many other deep learning tasks. Sequence classification is a predictive modeling problem where there is some sequence of inputs over space or time, and we wish to predict a category for the sequence. The sequence can vary in length, be comprised of very large vocabulary of input symbols, and may require the model to learn long-term dependencies between symbols in the input sequence, making this challenging problem for RNNs but easily solvable by LSTMs. Comes to the abstract part, deep learning has been in demand and is being used in different applications. One such area in deep learning is text prediction. Suggesting the next word in the sentence being typed makes works of user easier. Thus, text prediction feature to any application on the keyboard has become necessary to any user interface. This can be made possible by using recurrent neural network and neural model. But this project focuses on the implementation of text detection using long short-term memory, because in this mainly we are going to show how LSTM is effective than recurrent neural model. Next comes to proposed methodology. That is, first is data pre-processing. This area unit easy cleanup procedures that makes it easier to use the information in sequence steps. This method is administered with the assistance of TensorFlow library. The subsequent area unit few pre-processing steps typically done: marking white areas, lowercase conversions, removing numbers, removing punctuation, removing punctuation, removing unwanted words, removing non-English words. And the next is text analysis. To know the speed of occurrence of terms, term document matrix operator was accustomed to produce term matrices to achieve the account of term frequencies. Tokenization. One in every of the vital social control strategies is named tokenization. It's merely segmenting the continual running text into individual segments of words. One terribly easy approach would be to separate inputs over each house associate degree assigned and identifier to every word. Fourth is the paired sequences. When changing sentences to numeric values, there is still a difficulty of providing equal length inputs to our neural network. Not each sentence is constant length. Paired sequences operators employed for artifact the shorter sentences with zeros and truncating a number of the longer sequences to be shorter. Additionally, because it is often specified whether or not to pad and truncate from either the start or ending, relying upon the pre-settings and the post-settings for the padding arguments and truncating arguments. By default, artifact arguments and truncation can happen from the start of the sequence. Comes to our algorithm part of our project, the main reason behind adopting LSTM model is due to the problem with vanishing gradient descent in the neural network, which has an adverse effect on the weight update process and result in very less efficiency of the model. Whereas LSTM model has a hidden state and memory cell with three gates that are used to read an input gate. The forget gate is mainly used to get good control of what information needed to be removed, which is not necessary. Input gate makes sure that a newer information is added to the cell, and output makes sure what words of the cell are output to the next hidden gate. The sigmoid function used in each gate equation makes sure we can bring down the value to either 0 or 1. Recurrent neural networks are used to predict the next word in neural application. We choose LSTM because basic recurrent neural networks have a lot of fluxes. And the background of our project is short message service (SMS) permits a mobile phone user to send text message, also called messages, SMSs, text, and a short message. The most common system of SMS text input is referred to a multi-tap using the key is pressed multiple times to access the list of letters on the key. For instance, pressing the two key once displaying as A, twice displays as a K, a B, and three times displays as a C to enter two successive letters that they are on the same key. The user must either pause or hit the next button. The user can type by pressing an alphanumeric keypad without looking at the electronic equipment display. Thus, multi-tap is an easy to understand and can be used without any visual feedback. However, multi-tap is not very efficient, requiring potentially many keystrokes to enter a single letter. In ideal predictive text entry, all words used are in dictionary, punctuation is ignored, no spelling mistakes are made, and no typing mistakes are made. The ideal dictionary would include all slang, proper nouns, abbreviations, URLs, foreign language, words, and other user unique words. This ideal circumstance gives predictive text software a reduction in the number of keystrokes the user is required to enter a word. The user presses the number corresponding to each letter, and as long the word exists in the predictive text dictionary or is correctly disambiguated by non-dictionary systems, it will appear. For instance, pressing 4663 will typically be interpreted as the word good, provided that a linguistic database is English is currently in use. Through alternatives such as home, hood, and hoof are also valid interpretation of the sequence of keystrokes. The most widely used systems of predictive text are TGIX, T9, Motorola ITAP, and Etonic Ergonics, Letterwise and Wordwise, and T9 and ITAP use dictionaries. But Etonic Ergonics products use a disambiguation process, a set of statistical rules to recreate words from keystroke sequence. All predictive text systems require a linguistic database for every supported input language. Next is dictionary versus non-dictionary systems. Traditional disambiguation works by referencing a dictionary of commonly used words through Etony offers a dictionary-less disambiguation system. In dictionary-based systems, as the user presses the number button, an algorithm searches the dictionary for a list of possible words that matches the key press combination and offers up the most probable choice. The user can then confirm a selection and move on, or use a key to cycle through the possible combinations. A non-dictionary system constructs words and other sequences of letters from the statistics of word parts to attempt predictions of intended result of keystroke not yet entered. This ambiguation may be combined with the word completion facility. Either system disambiguation or predictive may include a user database, which can be further classified as a learning system. When words or phrases are entered into the user database without direct user intervention, the user database is for storing words or phrases which are not well disambiguated by the pre-supplied database. Some disambiguation systems further attempt to correct spelling, format text, or perform other automatic rewrites, the risky effect of either enhancing or frustrating user effects to enter text. Let's take an example. On a typical phone keypad, if user wish to type in multi-tap keypad entry system, they would need to press 8 TUV once to select key. If we press 4 GHI, twice to select H, press 3 DEF twice to select E. Meanwhile, in a phone with predictive text, they need only press 8 once to select the TUV group for the first character. Press 4 once to select the GHI group for the second character. Press 3 once to select the DEF group for the third character. The system updates the display as each key press is entered to show the most probable entry in this example. Prediction reduced the number of button presses from 5 to 3. The effect is even greater with longer words and those compared of letters later in each key sequences. A dictionary-based predictive system is based on hope that the desired word is in the dictionary. That hope may be misplaced if the word differs in any way from common usage. In particular, if the word is not spelled or typed correctly, is slang or some proper noun. In this case, some other mechanism must be used to enter the word. Furthermore, the simple dictionary approach deals with accumulative languages where a single word does not necessarily represent a single semantic entity. Next, companies and words, products. Predictive text is developed and marketed in a variety of competing products such as Nuance Communications, T9. Other products include Motorola's iTap, Yotoni, Ergonomics, Letterwise, character rather than a word-based prediction. Word-based word-based prediction without a dictionary. EQ3, a QWERTY-like layout compatible with regular telephone keypads. Prevalent device phrase Sergomix Tengo, a six-key reduced QWERTY keyboard system. Attached considers language, context, grammar, and semantics. LightKey, a predictive typing software for Windows. Clever texting, statistical nature of the language, dictionary-less, dynamic key allocation, and Voisia type, temporal ambiguity. Intilab Statu, world logic, intelligent input platform, patented layer based advanced text prediction, includes multi-language dictionary, spell check, built-in web search. And the next is taxonomies. Words produced by the same combination of key presses have been called taxonoms. Though they are not specific to T9, selecting the word taxonom can occur with no misspelling or typo. If the wrong taxonom is selected by default or user error, as mentioned above, the key sequence 4663 on a telephone keypad provided with a linguistic database in English will generally be disambiguated as the word good. However, the same key sequence also corresponds to other words such as home, gone, roof, food, and so on. For example, are you home would be re-entered as are you good if the user neglects to alter the default 463 word. This can lead to misunderstanding. For example, sequence of 735328 might correspond to either select or its acronym reject. A 2010 brawl that led to manslaughter was sparked by Textonym, the predictive text choosing a default different from that which the user expects as similarities with the Cupertino effect, by which spell-check software changes spelling to that of unintended word. Textonyms have been used as a millennial slang. For example, the use of word book to mean school, since book is the default in those predictive text systems that assume it's more frequent than cool. This is related to cacography. And the disambiguation failure and the misspelling. Textonyms are not the only issue limiting the effectiveness of predictive text implementation. Another significant problem are words for which the disambiguation produces single, incorrect response. The system may, for example, respond with Bleriff upon input of 252473 when the intended word was blaze or clear, both of which correspond to the keystroke sequence but are not, in this example, found by the predictive text system. When typos or misspelling occur, they are very unlikely to recognize correctly by the simplification system, though the error correction mechanisms may mitigate that effect. Thank you. I hope you like this video.